Hi everyone, thanks for tuning into another episode of Scale to Zero. I'm Purushottam, co-founder and CTO of Cloudanics. Today's topic includes Kubernetes security, both from an attack perspective and also from a defense perspective. We'll be doing this slightly differently than our usual podcast. It's more of a workshop style session today. And to do the workshop, we have Divyanshu Shukla with us. Divyanshu is a senior security engineer with over 6 years of experience in cloud security, DevSecOps, web application pen testing, and mobile pen testing. He has reported multiple vulnerabilities to companies like Airbnb, Google, Microsoft, AWS, Apple, and many more. For reporting the issues, he has received many CVEs as well. He has authored Burpomation and Very Vulnerable Serverless Application. He's part of AWS Community Builder for security and DEF CON Cloud Village crew member as well. He has also conducted many trainings and seminars in events like B-Sides, NullCon, IIT Dharwad, Girl Script Chandigarh University, and Null Community. Uh, Divyanshu, it's wonderful to have you in the show. For our viewers, can you share a bit of background and how you became interested in security and cloud native security in general?
Yeah, sure. So I started when I went into the engineering, I was not from the coding background. So like when I started, I was not able to grasp the basics of know how coding works. But before that, when I was in college, I used to do basic surfing, and I was able to understand how phishing works or back button vulnerability at that point of time in our code. So I was not sure of what I was doing, but I knew like this is not the regular stuff, and this is not like usually this should not be allowed. So I was like before
Mm-hmm.
that I was into commercial application. I was not into the computer, so I was not very much confident. But when I started my engineering, there I saw that apart from like software development, there are other fields as well, like networking and uh, like basically Linux admin was there at that point of time. Then no security. So I when I started working
Mm-hmm.
and learning, I was able to understand how Linux works. So Windows was always like a tough OS for me. So when I put my hands on the Linux, I was no was able to move around smoothly, and I was able to understand how things were working. So when I went into my first training in my first year of the college, at that point of time, I was
Mm-hmm.
able to solve the CTFs, no basic CTF and the packet tracer. So all those things helped me to understand that there is something else from the software development. So I realized that this is something I knew from the past. When once I was able to correlate, looking the dots backward, and at that point of time, I decided to pursue it as a career. So then I went into the networking trainings, and I did my CH training. So I just did the training because I always assume, or like I always think that no certifications are not that important. It's about the skill. So I started picking up these skills and no trying to do hands dirty on the like ISPs, like the local ISP providers and the routers and switches. So I was able to like no move around the things. I was able to find issues in my own no ISPs. So that's how I started. Then
Mm-hmm.
I went into the internships, did couple of internships as a DevOps intern. Then once I was very much confident about the Linux and networking, I started working as a full-time security engineer. And from there, I picked my path, did all that pen testing, did DVWA, vulnerable applications, and so on. So because I had previous knowledge about the DevOps and Linux administrator, I quickly picked up the cloud. So I started cloud. It was new in 2016, 17 companies were moving in the cloud, and it was new. So I knew that one day or another, like security would come into the picture. So and I had
Mm-hmm.
that knowledge. I was able to troubleshoot. I was able to understand how the cloud infra was working. And so that's why I started learning. And meanwhile, I was doing my pen testing and bug bounty. So once I was working as a full-time pen tester, I got the opportunity in one of my previous organization to look into the cloud security also. Basically, it was ELK, monitoring the logs, and no creating the use cases on the threat hunting of the cloud attacks. So that basically
Mm-hmm.
helped me to build the basics of cloud security. And then in my last organization, I was doing it as a full time engineer, where I was performing these scans via open source tools, then doing CSUT scan, and understanding different CSPM tools. So because I had a pen testing background and now I got the idea about scanning the cloud network, I was very much good to
Mm-hmm.
go and perform the red team assessments and taking care of the entire infra. So that's how I landed into my current role, and I started leading the cloud security for my current organization. So that's how my journey started, and this is what I am today. So I am moving towards the Kubernetes and GKE and other clouds as well, because it again depends on the
Mm-hmm.
organizations. Because in the lab you can do couple of things, but in reality, unless you are not doing a a scan or the audit of real environment, you won't get that idea how the infra is actually set up in the real environment, because of the scale and the size
Correct.
we when we talk about. So these are the things like how and what I've been doing till now. So thank you, and over to you, Pushottam.
Yeah, thank you for sharing your journey. One of the things that I like, there are two things that I could like uh, that's stuck out. One is you were always a hands-on guy. Like that's how you started, right? Instead of going by the books, you have always played with the system in a way. The second thing is you have picked an amazing domain, which is security. Like I was at like Forward Cloud Sec and AWS Reinforce this week, and the amount of innovation I see like makes me very happy that we are in the right domain. So I'm looking forward to learning more as part of the podcast. So before we start, one question that I ask all of our guests is, what does a day in your life look like? So how does it look like for you today?
So for me, currently, it starts with looking into the any issue which has come up in the cloud. Especially when I do, it's mostly the AWS right now. So it can be a attack on the WAF or any DDoS kind of a scenario, or some like this is just one part. Sometimes it is the developer trying to set up a application and they need IAM access, so reviewing those access, generating the IAM rules for them. So these are the common things which I have done today itself, and the next part involves mostly around doing an automated scan via open source tool or the cloud nx itself, to see what are the issues, then basically going and validating those issues in the environment to create a POC for the DevOps teams and the developers, and then helping them to fix. So this, like just before this our discussion, I was discussing with our team and the developer that what things are required for like when they are creating a user in the environment. Like there was a specific scenario. So
Okay.
these are the things which I do like in my day to day life, and like most of the things I've done today itself.
Okay. So again, very hands-on
Sure.
work, like looking at different attack vectors and how you can both attack and prevent as well. So that's a good segue to the workshop, right? So let's get started. If you want to share your screen, and maybe we start with Kubernetes and what are different attack vectors and how you have, let's say, you can attack a Kubernetes cluster. What are different ways, and we can go from there.
Yeah, sure. So in this workshop, basically, I'll be showing you a documentation where I have written the steps,
Mm-hmm.
so that if no, if anyone is looking into a screen and no, if they don't know the command, they are well aware like what exactly the command looks like and how I'm like moving
Mm-hmm.
around. Because if I'll do from somewhere from copying and pasting directly, like the person or whoever is looking won't be able to understand right which command would come next, like out of the blue. So that is why I'll be following the approach
Correct. Correct.
which is most from the trainings which I have given. So I'm starting to share my screen.
Okay. Yeah, that's lovely. That's lovely. At least our audience can go through the documentation as well and follow along when they look at the podcast.
So this is the name of my training which I usually give. So for here I'm not changing it. So it's
Okay.
the workshop on defending and attacking Kubernetes. So
Okay.
here
Lovely.
we'll have a demo. Basically, it's usually it's more of a hands-on, but right now it would be a demo kind of a
Mm-hmm.
presentation, and I'll do most of this stuff.
Right.
And there would be a vulnerable application. So if I'll get time, I'll try to show how the application looks like, and if not, I'll show you
Mm-hmm.
the YAML and the source code. I'll try to cover things based on the time. So let's get started. So
Okay.
before that, like
One
these
question
things,
before we
yeah,
start.
sure. Mhm.
Go ahead. Go ahead. Why don't you finish?
Yeah. So before I start the disclaimer which I have put in, so these are some real life attacks which I have learned over the time. So do not just
Okay.
no perform these attacks into the environments where you are not authorized. Like this is just the educational
Mm-hmm.
sessions for the security engineers or anyone who is more interested to understand the Kubernetes security. So that is over to you,
Okay.
Pushpita.
Yeah. So one question I had is the URL that you are going that you are at. Is that publicly available all the time so that we can share it with our audience?
No, it is shareable for this session. Once our session is complete, this would go down. So because
Okay.
it's
Okay.
like a proprietary content. So right now I'm still
Okay.
working on
Okay.
no setting up these things. So that is why I can't share. Maybe in future I'll do that. So I'll paste something in the comment
Okay.
section from where folks can pick it up.
All right. Makes sense.
Um, so that is pretty much. Let's get started. So first I'll go to my
Yeah.
EC2 instance. So it is Cloud9. I've
Mm-hmm.
set it up, and like I'll start explaining the configuration which I've used, and I'll also explain
Mm-hmm.
basics of how I have set up the cluster. So this cluster has been set up via Kind. So Kind is uh, uh, a software or an application which helps to deploy the Kubernetes cluster into a local environment using the Docker. So when we talk
Mm-hmm.
about deploying a real cluster, we know we need a master and a worker node, which can no worker
Right.
nodes like one worker node or two worker node, which can connect to the master. So in single lab, like that is not possible because then we need three EC2
Right.
instances and then we have to set up. So it will take time. So that's why we'll move. We'll use Kind and we'll set up the no cluster using Kind. So I'll
Okay.
just
Makes
go
sense. Yeah,
through.
I have used a
Mhm.
kind in the past, and it's fairly straightforward to use
Correct.
as well.
Correct. Correct. So I've tried basically using K3 as Kind, Minikube, and CubeADM, but like for this lab, it was most appropriate to use Kind because of the Docker underlying Docker it was using, plus the kind of attack I wanted to
Mm-hmm.
show were possible in the Kind cluster. Like although I needed CubeADM, so my main
Ah.
lab
Okay.
which I have, if you will see this lab which is running on this ngrok free URL. So this lab is deployed using
Mm-hmm.
CubeADM because it is the actual no, way of deploying the Kubernetes cluster.
Right.
So
Right.
that is why I've
Okay.
used
Makes sense.
in CTF section or like in main lab I've used it the CubeADM, but
Mm-hmm.
for demonstrating multiple attacks where I have to delete the cluster or redeploy multiple apps, I just wanted to have a no
Mm-hmm.
seamless way of doing it. So that's why I picked up this Kind.
Right.
So
Okay.
I'll
Makes sense.
just go through the basic of like this. The Kind, it says the cluster. So basically
Mm-hmm.
we are deploying the cluster. Then it talks about the
Mm-hmm.
version. So if we are using this v1 alpha 4 version, and then in the nodes
Okay.
we have control plane, and if you will see there are two worker nodes. So in the control planes
Mm-hmm.
these extra mounts are there. So usually these things are not required. If I'll remove these things, then also my cluster would work, but I wanted to demonstrate the
Okay.
attacks. So that is why for like a
Mm-hmm.
couple of attacks these docker.sock mount point was required. So that is why they have
Okay.
it is basically mounted. And then if you'll see in the
Mm-hmm.
last, this networking default disable default CNI is true. So which says like I
Mm-hmm.
don't want Kind to deploy the default CNI which it is using. So instead of that, I have
Okay.
deployed the Cilium. So if you have heard about Cilium, it is an advanced
Ah. Okay.
network wrapper no or fabric which is used to no take like which uses eBPF technology to block provide much level granularity in the terms of network security, like if we talk about in the
Right.
layman
Right.
language. So that is why I'm using
Okay.
Cilium with the Kind.
One question that I have is the
Mhm.
attacks that the processes that you will show. Will they
Mhm.
work with the default CNI as well? Like if somebody doesn't want to use Cilium or doesn't have Cilium, let's say in production, will these
Yes,
attacks
yes,
work or
yes.
these will? Okay.
So these attacks
Okay.
would work in all the environments except the part where I'll be showing the Cilium itself, how the Cilium blocking and like in the
Ah.
defense
Okay.
section Cilium works. So for that we would explicitly need Cilium.
Mm-hmm.
But other than that, everywhere Flannel or no like Weave or anything would work. like whichever network fabric
Okay.
like the users have.
Okay.
So
Makes sense.
So let me jump on to like I'll see if I can have something from the basics. So like let's start with
Sure.
the container first because Kubernetes comes after that. So container is no.
Mm-hmm.
Let me zoom in before that. My apologies. Yeah. So basically, container is kind of a virtualization where we have a application running on a container D or no runtime, and it came after the VMware or the VirtualBox came into the picture where we had a host and no a VirtualBox was taking our memory from the host itself, and it was a separate operating
Mm-hmm.
system which consumed our RAM and no the space itself. So then
Right.
like containers came into the picture, so it was like a ship itself, as you can see, where we have different containers, and no inside each container we have different things. So let me give you an easy example. So when we
Mm-hmm.
talk about container, we have no a ship is basically like moving from maybe no US to India, and there itself like we have fishes and the paper. So in the one container we have fishes. So for the
Mm-hmm.
fishes we basically require ice and no a colder environment. And for the papers or
Mm-hmm.
like maybe a newspaper or any kind of book or something, so for that I need a hot environment which is non-humid so that no books are not spoiled. So in those cases we need
Mm-hmm.
different things, or like the requirements are different, but we don't need two different captains or
Different
like two
setup.
different teams, yeah, teams to do all things, right? So when we talk about virtualization, imagine
Mm-hmm.
we have an ship, and inside that we have two more ships which are managed like by different captains, right? So we basically have three captains
Mm-hmm.
which are consuming the resources from the
Right.
same ship. So it is kind of a overburden. So
Mm-hmm.
when container came into the picture, now we have a container box where we have provided the electricity
Mm-hmm.
for the refrigerator to run, and there it's all cold and no
Mm-hmm.
freezing, and our fishes are safe. So in the another container now we have
Mm-hmm.
books and newspapers where we have a maybe a hot environment, and now our papers are also safe. But the captain is same, team is same,
Right.
and now my ship is traveling, right? So I can use one single resource, and based on
Mm-hmm.
the environment I can do whatever I
Mm-hmm.
want. Now so now I can stack my ships, and I can have more containers, like based on obviously the ship of the size of the ship. So I can have more containers, and I
Mm-hmm.
can do much more, like with the same amount of team, like a captain. And so it's similar to resources we have on the host operating system. So that's how like the
Right.
container
I
works.
I
Mhm.
love the. I have never heard this analogy, but I still love the analogy because it in real life it talks about containers and how shipping and everything works. And so yeah, thank you for sharing that. I love that.
Thank you. So basically, this is the diagram which shows the same. So we have a virtual
Mm-hmm.
machine on the left, and then there is an hardware host OS and hypervisor. And
Mm-hmm.
the technology which was used in the past was hypervisor and apps, and the guest OS was installed. Now these guest OS are used to share all the resources till the hardware level. So it was like your virtual basically your host OS would be very slow, and there would be sharing of RAM. So it would take whatever, like if I'll give 8 GB of RAM into my guest OS one, for the app one it will take everything, right? So that is not
Mm-hmm.
required when we talk about running an application with a specific requirement, maybe a Python application or maybe a .NET application.
Mm-hmm.
So in those cases, we need very specific requirement. So let's suppose I want to
Right.
have a no a Python application running on Ubuntu. So I can have a Ubuntu image, and which will use the
Mm-hmm.
container engine, and we can have a
Mm-hmm.
like a container with Ubuntu minimal no requirements, and then inside that we can have a Python version. So then
Right.
everything is again shared, but it is like same to the analogy which I have given, where like the resources are shared based on like how your normal or regular process works into the host OS. It would be a similar to process,
Mm-hmm.
not sharing your no hardware, or like taking a part in the hardware. Like it won't be segregated as in the case of virtual machine.
Makes
So
sense.
that is pretty much container, and for that this is exactly like then we'll talk about Docker. So Docker is an open source platform for building, shipping, and running containers. It is just an
Mm-hmm.
platform, and it is because it is easy to use and it is readily available and everyone is using. So that's why it is very common, and like everyone is deploying applications. No, in containers using Docker itself.
Right, right.
So that is like the my next image is a Docker file. So Docker file is used to create the container images. So first we have a Docker
Mm-hmm.
file from where the image is created and it is uploaded into a repository. It is very much similar to the GitHub code, but in the case of container repository like Docker Hub or ECR, we are uploading the images which we have created. So this Docker file would
Mm-hmm.
contain the set of commands, and these commands basically will say, as you see from Ubuntu. So this is the base operating system which we were talking about. Then copy is just copying my code,
Mm-hmm.
and then run pip install is just running the pip and installing the requirements, and it is exposing the 1990 port, and then the CMD is running my command. So it will run,
Right.
it will create the image as you can see on the right side in the similar way.
Mm-hmm.
So that is pretty much about the like how the images work. I'm not going much into the control groups and namespaces because that is like a very wide topic, but I can talk about that in
Right.
a brief. That control groups are used to
Mm-hmm.
limit and prioritize basically the CPU memory and IO bandwidth. So they provide like
Mm-hmm.
a kind of a separation that one process or one group of processes do not interfere with others. Similarly, we have the namespace.
Right.
So namespace is a kind of a, again the like there are a couple of namespaces like no network namespace, file system namespace, which is basically used to isolate the host from the this container which is running. So every time my
Mm-hmm.
like container would run, it would be in the separate namespace, so it won't interfere with my host
Right.
process or my host network. So this is the place where the vulnerability arises in cases or the misconfiguration, I would say, when the container is configured in a way that it requires something from the host, like a file system or maybe the process,
Mm-hmm.
and we are overexposing these things from the host. So the attacker, if they have
Right.
compromised the containers or any malicious process if that is running in the container, it can just come
Mm-hmm.
outside and try to take over the entire host or try to like attack on those specific file system or that no perform the breakout kind of scenarios which we will see in the later section of this workshop. So
It is somewhat similar to like overprivileged IAM permissions, let's
correct,
say, right?
correct,
Using that,
correct,
you can attack an AWS account and or GCP account or Azure account, and
correct,
then
correct,
get access to the whole
correct.
account in a way. Whole all. Yeah,
That's correct.
makes sense. Yeah,
So
let's continue.
yeah, so that is pretty much it. We have some couple of namespaces I've given, like PID namespace, mount
Mm-hmm.
namespace, and user namespace. So out of which mount
Mm-hmm.
namespace we will see where I will be mounting the file system of our host into the container. Like if my container want to access a specific file system or something which is present in my host, in those cases I'll mount my namespace there. So and we'll see how
Mm-hmm.
attacker it is possible for an attacker to perform a container breakout, and these things actually help in the
Okay.
real world when we have a misconfigured clusters or when the teams are not no very mature or they don't know the Kubernetes or container security. In those cases they will have misconfigured clusters, and in the case of like
Mm-hmm.
the black box pen testing also, where no you have found an RC or you are inside the container, or in the case of like
Mm-hmm.
gray box pen test also, where you found an internal way, maybe during the audit or something, a red team internal red team assessment, you got access into one of the application which was running internally. In those cases, once you are inside the container, it would be easy to break out and take over the host. And once you have the host, these days the containers are running onto the AWS environment, so those hosts will have some kind
Mm-hmm.
of no PEM keys or maybe the overly permissive roles or like any hard coded keys, which will lead to the like complete AWS
Right.
takeover. So that is the
Right.
containers.
Right.
And Then we talk about the orchestration. So because we have multiple, like we are talking about one or two container, but in the microservice or architecture, we have more than 1,000 or maybe 10,000 containers in cases. No, in those cases, how we'll manage them? So like the deployment and
Mm-hmm.
management and scalability and the networking. So all these things need to be managed, right? If my container died while I was trying to deploy it in the production, how I'll bring it up? Like how I
Mm-hmm.
would basically get to know that
Right.
it has died, right? So for these things, we have something called as Kubernetes. So it is an orchestration
Mm-hmm.
engine that solves this problem, and it is backed by the Google. And like
Mm-hmm.
we basically, by using Kubernetes, we can orchestrate the deployment of these containers into the infrastructure, and it is very easy to
Mm-hmm.
restart the pod and no check whether the container is not running, or there is some issue with the container, or it is taking, or like if we want to do the deployment, or if we want to update an application. So in those cases we can use the Kubernetes, and it makes it very easy for us to go and know understand how basically our infra is working. So for this
Right.
workshop, I'll be using the Kubernetes YAMLs, which basically are used to deploy infra in the real world as well. So lab scenarios
Okay.
might be little bit different, but somewhat they will overlap with the real scenario, as the YAMLs are created in the similar way. They are uploaded into the Git repositories. So if we talk about from the security engineers perspective, in those cases, no, we perform scans on via TFSec or Chekhov on these infra no, IAC code, so where it will have YAML as well. So from there also we'll get an
Right.
idea what kind of misconfigurations are present into the deployment
Mm-hmm.
itself, so that we get to know before it is deployed, and then we can ask developers or DevOps team for the fix. So that is how basically it
Okay.
happens in the real world.
Sure. So in the next section, we'll talk about deploying a vulnerable application and how the YAML looks like and how the security testing is done. So there were a couple of phases
Mm-hmm.
where I wanted to talk about the RBAC and how RBAC works. But for this workshop, I'll go through within the lab itself. I'll explain what
Mm-hmm.
is authentication and authorization and what do we mean by in terms of the Kubernetes infra itself. Then I'll show the YAML, which
Okay.
is basically used to deploy an application with overly permissive permissions. And we'll see how it increases
Mm-hmm.
the attack surface. And I'll also try to get a reverse shell, and I'll try to
Okay.
no like get I'll basically try to show what do we mean by overly permissive no RBAC in the real world scenario. So let's get started. So, as we
Yeah.
have discussed that Kubernetes testing is, basically the testing of Kubernetes cluster, or because all the applications will be deployed on the, a pod. So, pod is nothing but a smallest unit in the Kubernetes. So, when we talk about the Docker, or
Mm-hmm.
we usually say it is container, but when we talk about the Kubernetes, it is the pod. So pod is nothing but a container. So usually we assume that in pod we would only have one container running, but in some scenarios we can have
Correct.
two or three no containers running within a pod. So let me show you. So if I'll run
Mm-hmm.
kubectl get pod, so you will see right
Mm-hmm.
now I have this one/1. So this is our pod. So we can have
Mm-hmm.
2/2 also, where we mean that in one of our pod we have two containers or more containers running based on the number. And this is so.
Okay.
Before that, I just want to explain this kubectl. So kubectl is uh, an application, I would say, which is used to or a CLI tool which is used to communicate to the Kubernetes cluster. So in Kubernetes cluster, let me just kubectl, yeah, kubectl. So I'll show you the nodes as well, how many nodes we have, and how our cluster is deployed right now.
Okay.
So if you'll see, we have this control plane and two worker nodes. So all these are running inside a
Okay.
Docker. So kind is basically using the Docker. No, just a second. So kind is basically using the Docker as its overlaying technology. So that is why these worker and the control plane,
Mm-hmm.
everything is deployed in the Docker itself. So it is a Docker and Docker scenario. So whatever these worker nodes are, they are
Okay.
running on the top of a basically a container. So this is what it is. And
Right.
then when we talk about the real scenario, we have a control plane or the master where are all these worker nodes would
Mm-hmm.
talk to, and where everything would work. Right. This is basically the behind the brain of our Kubernetes. It is the master. Right. So in EKS or
Mm-hmm.
GKE, in those clouds, we don't have master no or the control plane exposed. So if you are in the EKS and you will run kubectl get node, you won't get the control plane because you directly can't access it. Because this is a demo cluster, or in the clusters where they are deployed on the EC2 instance, like where we are deploying the master itself. In those cases, we can definitely see it. But right now, when we talk about the cloud, we don't have access
Mm-hmm.
to these no the master nodes or the control plane. So when in those cases, we will only see that
Right. So that
worker
is
node.
the
Mhm. Yeah, yeah,
sorry, that is the managed piece of the cloud, right? They manage the
correct, correct,
control plane, so that you just focus on your nodes. So it makes
correct,
sense.
correct. So that is basically helps developers and DevOps. But as a security engineer, if we can find a way to take over the control plane in the cloud environment, that would be a no big, I would say, big misconfiguration of the vulnerability. But obviously, they have their things in place, and it is
Right.
like people are trying, so it is not possible where anyone would come and they would directly hack into the master or the control plane of the cloud. So we
Control.
can assume,
Right.
yeah, we can assume that they are safe, and like the control plane itself is safe, and we just have to focus on taking care of the worker node security. So
Right.
this is the two worker node, and so it is a three node cluster. And in control plane, when
Mm-hmm.
we talk about this kubectl get pod, so this request reaches to your API server, which is inside the control plane. And then control plane would
Okay.
check, and it will see into its no headset, which is a key pair kind of a DB, which keeps the states and how many pods are running, these kind of things for like uh, maintaining and tracking it, right? So like this would basically
Right.
help us to know that how many pods are running, and that's how we got the pod. So this is the a layman architecture of Kubernetes. Since we are talking more about the security, I just wanted know everyone to go through the Kubernetes basic architecture. Although I'm not explaining these things in detail. So
No, but thank you for doing that. Right. It helps for somebody who is starting in Kubernetes. They can also understand what are the basics and then get into the attack side of things.
So basically, these topics are very huge in itself. Like when I started, it took me like around 1 month to understand how these deployments happen in the cloud, and how these deployments or this master is working in the a demo cluster. Because there you won't be able to see
Mm-hmm.
anything, right? And everyone, like especially right now, folks are starting in mostly into the EKS or GK. So they won't
Right.
get all these things. They won't it is there are a couple of things which changes, right? So that is why it is a easy way of understanding the basics. And then when we move towards EKS in the future, or if someone will go through the documentation, they would be aware that no like they won't see the control plane because it is managed by the AWS itself.
Correct. Correct.
So now, when we talk about the security risk, since we have containers running
Mm-hmm.
and anyone can deploy the containers, there is an increased attack surface.
Mm-hmm.
And then the second thing, if you remember from our no images where we were using a Docker file to create the image, in those scenarios also, if someone has created a malicious image, a base image, and they have uploaded onto the public
Mm-hmm.
on Docker Hub or anywhere public, and we are pulling it from there, so there also it can be a
Mm-hmm.
backdoor, or it can be a image vulnerable with an old CV, which can create havoc. Then the next thing is threat actors, right? Anyone, it can be an internal or an external
Mm-hmm.
person who is having access, maybe to connect to the master, or the talk to the API server, or any internal user. right? Or maybe a disgruntled employee or someone who basically tries to get data or tries to exploit the Kubernetes cluster and have some kind of benefit out of it. So those threat actors can have
Right.
some kind of permission with them, and then they can try to basically exploit it. And
Mm-hmm.
then we have the malicious containers itself, like the backdoor containers. So there is a very a thin
Mm-hmm.
line between a vulnerable container image and a malicious container, because no, in images itself we can have CVs or the vulnerabilities. So that would be more or less like a vulnerable container image, and malicious containers are those containers which are directly having the backdoor. So the moment you will deploy those backdoor no containers, backdoor images, they will give attackers a reverse shell. So that is more of a malicious container, or a
Mm-hmm.
container maybe once we ran it, it starts scanning the internal network. So those are the malicious containers, which they are not directly
Right.
no vulnerable, or they cannot be exploited by any user, or but they would exploit something, or they would try to scan the internal network, right? So this is a very thin line, I would say,
Right. Right.
between the two. And then the insider threat and the malicious threat actor, they would lie again somewhere between them. That threat actors can be anyone, like if I am performing an external scan of some bug bounty program, so or any malicious user is
Mm-hmm.
doing that, so we are considered as a threat actor, because we are trying to find an issue. Then
Right.
I, as a as a bug bounty or a hunter or a security engineer, out of the good faith, I would go and report it. But those who are not
Mm-hmm.
doing it in the good faith, they want to exploit something or gain out of those scenarios, they would go and they would start exploiting those scenarios and maybe try to exfiltrate the data out of it.
Right. Makes sense.
So, and below are the security best practices. So, first one is authentication and
Mm-hmm.
authorization. So, authentication and authorization in Kubernetes is when a user is created into the Kubernetes cluster, right? By default, there
Mm-hmm.
won't be any access. So, in if we talk about authentication or authorization in general, we can assume that no, we are going into a plane. So we are authenticated to get inside the plane, but we
Mm-hmm.
are not authorized to get inside the cockpit where the captain would sit and like he would fly or she would fly the plane, right? Because we are not authorized to do
Right.
that. So we can have a basic set of, maybe we can have a checklist or a name that my name is there or my user is there. Like if we talk about AWS, right, where everyone can relate. So I have
Mm-hmm.
a user created, but I have not attached any policy to that user. So in those cases, user won't
Mm-hmm.
be able to do anything. So that is the authorization part. And the creation of that user into the AWS environment is the authentication part. So that is how the authentication and
Mm-hmm.
authorization work. So in Kubernetes, whenever a container is deployed or a pod is deployed, that pod needs some kind of permission to talk to the Kubernetes cluster or the different pods within the network or into the different network, like based on the requirement. So in those cases, just
Right.
or any
Right.
user, I have got access right now because I was able to run kubectl get pods because I was admin. I had all the privileges. But if I'll
Right.
create a user, maybe
Mm-hmm.
your user Purushottam, in those cases, until and
Mm-hmm.
unless I won't give you the permission, right, to maybe list the pod or
Mm-hmm.
create the pod. So until unless you don't have those permission, you are not authorized to perform these kind of no activities. It is similar to the
Right.
HTTP verbs when we talk about like the kind of verbs we are allowing as the part of authorization in Kubernetes. So that is what authentication and
Makes
authorization is.
sense.
Yeah. So I will also show that. And the next part is the network security, where the two networks, basically two pods, are communicating no, within the namespace. So I just wanted to add here before I move to the next part that by default, namespace do not block any type of communication. So I've seen people assuming that
Mm-hmm.
my applications are running in different namespace, so they are separated and segregated. But that is not true. Like namespace just isn't just a logical no separation when we are running pods or anything in the Kubernetes cluster.
Mm-hmm.
So, and the next thing is CIS security scan. So, CIS is just a benchmark for the best practices which we can use, where a bunch of no like-minded Kubernetes security folks came up and they created some best practices which are easy to follow, and everyone can have a basic idea, like if they want to secure their Kubernetes cluster, or if they want to find the no misconfiguration, what are the common things they need to see. So this is our CIS security,
Mm-hmm.
and then self assessment of the security in the cluster is about doing the pen testing of the cluster, doing the red team assessments of the Kubernetes cluster. What are the entry points? What are the exit points? What
Okay.
are the vulnerabilities? And then trying to exploit those scenarios, or maybe find something which can lead to a DOS, or a complete cluster compromise in the worst case.
Mm-hmm.
And the last part is infrastructure pen testing and patching. So when we deploy Kubernetes, no, we usually do it in the EKS or GKE, right? So we have to make sure that our Kubernetes, apart from our Kubernetes cluster, our no AWS or the our cloud itself is safe. Like if I'm a user and I
Mm-hmm.
have full permission to create or deploy the cluster itself, I can right. I would have access to everything. Like in those cases, I can create my own user and do whatever I want. Maybe I would go and simply delete the cluster, right?
Right. Right.
Because now I have access. So I can have a DOS without even having access to the cluster. So these are some common best practices,
Correct. Correct.
and some of the scenarios we would see in the next lab. So before that,
Okay.
if you have anything, Purushottam, you want to discuss or anything, then I would be happy to answer before we move to the hands-on scenario.
Sure. One thing that I want to double click on is
Mhm.
where you highlighted, right? Just
Mhm.
because there is a namespace, like you're deploying your workloads into two different namespaces, that doesn't
Mhm.
mean the communication is
Okay.
not
Okay.
there. Like by default, it's allowed, right? Which
Correct.
a lot of folks maybe do not know. So thank you for highlighting that. And I love your analogy as well about the authentication and authorization in a plane. So yeah, I'm all good. Let's move to the one of the scenarios of attacking a cluster.
Okay, so just let me see where we are in terms of the application itself. Let me just check whether my application is running or not before we move.
Sure.
So although I
Yeah.
have deployed,
And what does this application do? If you can briefly
yes,
share
sure,
what this
sure. So
application is.
before that, I'll just go into the hands-on part as well. I'm just checking where I have deployed this application, so
Okay.
that I can just show the explanation and the flow. Yeah. So just let me
Okay.
start my application. So before that, I'll just sorry, it is in this. Four dot. So this is our. I'll just explain the YAML, and then I'll explain the application, and then
Mm-hmm.
I'll show you how
Sure.
basically our application is working. So I'll just open these
Okay.
files. So first it's obviously come to that like our back part. So in Kubernetes, we have
Mm-hmm.
roles and role binding, and cluster role and cluster role binding. So in role, it is
Right.
typically named to a namespace. So when we talk about this, right, kubectl get pods. So
Mm-hmm.
you will see I can only see one single pod. But if I'll do something like this where I have kubectl get pods, no hyphen a, yeah. So you
Mm-hmm.
will see now with hyphen a, which means all, I was able to see multiple pods, right? So you can see with the pod
Mm-hmm.
command, it is segregated by the namespace, right? With different namespaces, we are getting different
Right.
results. But when I do, sorry, I was not on the
Mm-hmm.
tunnel. Let me zoom in here also. Yeah. So when I do kubectl get nodes, so
Mm-hmm.
in this case, you will see I'm still getting uh, three nodes, right? So if I am, this is free from any
All the nodes.
namespace, right? Like it is not any name, no namespace
Right.
is specific. Like whether I am in any in namespace A
Mm-hmm.
or the cube system namespace or any namespace, this would show me only three nodes. So there are some permissions which
So
are
there are
bound.
few resources,
Mhm. Correct. Yes,
right?
yes,
Like
yes.
few
Please go ahead.
resources which are within namespace boundary and few which
Correct.
are not, right? And also you have
Correct.
permissions to access some and not some others. Makes sense.
Correct. So then we can on that only we will assume that how the permissions need to be given. So for the permissions where we want
Mm-hmm.
application to access a specific namespace or no a specific part of the cluster, right? So in those cases we would go
Mm-hmm.
into the role basically role bindings. But when we want to give access to the
Mm-hmm.
entire cluster, we would move towards the cluster role and cluster bindings. So this is a
Okay.
basic scenario, and
And
in this,
in which
Mhm.
case would you use just the role?
So we would use role. Suppose I want to give access to a specific like namespace, right? I want user to have access to this cube system
Mm.
namespace for a specific set of pods. Like I
Mm-hmm.
want X user or like Purushottam user to see only the cube system namespace. So in those cases, I would give no
Okay.
role and role bindings, because I just want
Uh,
user to
okay.
access this specific right. If I want you to access all the nodes
Mm-hmm.
and all the namespaces, so if I'll create a role for every
Mm-hmm.
namespace, it will take 10 files to YAMLs to be created, and then the deployment would happen, right? So again, it is we can do
Right.
in a different way, but this is the way how this it should be done.
Right.
So
Makes sense.
and cluster role is where we are giving the full permission, basically cluster wide permission, not the full permission. And when we talk about the misconfigured cluster role or like overly permissive role, it always starts with a star. So if
Mm-hmm.
you'll see star everywhere, like we can see here, yeah, the API groups are star.
Right.
That means all the API groups, no, like within the Kubernetes are allowed. Then what kind of resources like pods or the namespace, everything is again start, and the
Mm-hmm.
kind of verb like the list verb or the delete verb or the
Mm-hmm.
create verb. So these are the verbs. So everything you'll see is star here, right? And the kind is cluster role. That means we are creating a
Right.
cluster role, and this is the name of our cluster role right now. Like your name, my name. So this is just the
Mm-hmm.
name itself. So next
Right.
is the binding part. So what do we mean by binding, right? And why I'm taking this
Mm-hmm.
name again and again, that some role binding or the cluster role binding. So we have to tell
Mm-hmm.
Kubernetes that this cluster role is associated either with a person or a service account. So when we
Mm-hmm.
talk about bindings, it is just to tell that no, my this role or the cluster role or the role, this would be associated to Divyanshu user or a Purushottam user. So that at every time Kubernetes master
Mm-hmm.
node sees that no, Divyanshu is trying to access, so it would know that based on the permissions in the this X cluster role, which is binded here, as you can see here, user
Mm-hmm.
or Divyanshu can access.
Mm-hmm.
And in case of machines, we don't have like username or password, like machines can't go and log in, or like they can't
Right.
create the certificates. So for that we have a service account. So service account
Mm-hmm.
is basically mounted inside a container,
Mm-hmm.
and from there, based on the permissions this service account would have, my container would be able
Mm-hmm.
to communicate, my container would be able to talk to the node, my container would be able to create more pods, or the maybe it is able to list the pods or do whatever it wants. Like it can be a requirement, right? For some communication or some creation. So that is
Right.
why the
Yeah.
permissions are given. Yeah. So this
Right.
scenario is
So
basically based
binding
on that.
sounds.
Mhm. Yes, yes.
Sorry, I was just saying, like binding sounds like how, let's say, in AWS, you have
Hmm.
a policy, which is very much
Hmm.
like your cluster role, and then you
Correct.
have a user or a access key, and then you are attaching the policy to that user. So that is the binding in Kubernetes context.
Correct, correct. So it is more towards the Google, where the Google itself uses the service account. Like if you know that no,
Correct.
like the
Correct.
machines would have service account. This is exactly similar to that only.
Mm-hmm. Right.
So in this scenario, we are just creating a cluster role with overly permissive role. You can see the star star, and I'm binding it to a service account because I would run an application, and then we would try to
Mm-hmm.
basically. no exploit this application and get inside this application by RC. So once we'll have RC, I'll try to no do
Okay.
couple of things which I'll show you. And this is the deployment of
Okay.
my application. So the kind type is deployment. So there are multiple types of
Mm-hmm.
deployment, or like multiple ways to deploy a pod. Like pod is there, stateful sets are there, replica set is there, deployment is there. So there are multiple ways by which you can deploy a pod or a container. So pod in pod, like I'll explain
Mm-hmm.
one of, like in the pod, when I use or mention something like pod, right? Then my pod or the my
Mm-hmm.
container created, and if that container dies or it exits, right, in that case it won't
Mm-hmm.
come up automatically, like it will just stay in that state. But in the
Right.
case of deployment, you can see, right, my replica is set to 1. So this is the desired
Mm-hmm.
state, and my if my application or my container dies or my pod dies, then it would come up again. So my
Mm-hmm.
Kubernetes cluster or my master would try to
Mm-hmm.
keep on, like bring it up, like no every time if this container would die. So that is why we are using it, the deployment,
Right.
right? So
This is where
and here,
Kubernetes helps, right? If
correct,
you have
correct,
defined
correct.
replica, then Kubernetes will make sure that it is those
Correct.
many number of
Correct.
instances are available.
Correct. This is what I was trying, like, was
Yeah.
planning to add, that no, this is how Kubernetes comes into the picture. Like, if we had a container, then
Mm-hmm.
we won't be able to do this thing, right? Our pod won't come up every time it dies. So
Right.
then we have couple of labels. So label is like the no tags which we are
Mm-hmm.
adding. So if we want to manage our pod or anything based on the label, we can do that. It is similar to any tagging system
Okay.
where wherever we use, like in AWS or anywhere. So it is exactly similar to that. And
Mm-hmm.
then we have this service
Okay.
account name. So you'll see the service account name is attached here.
Mm-hmm.
So this is the service account. So if you'll see my binding, I have created this service account, and
Mm-hmm.
this is I am adding it here. So
Mm-hmm.
now my application would use this service account, and this whatever permissions
Okay.
this service account would have, my application would have the same set of permissions. And
Right.
the last part is this image, which is the insecure Python app. It is on the Docker Hub, and this is the name of my repository. So it's nothing
Mm-hmm.
else. It is the main
Okay.
part is this insecure Python app, and it is running on port 8000. So I've
Mm-hmm.
just mentioned that container port is 8000, and my image is this from where the Kubernetes would
Okay.
pull this image and would create a container, and it will mount
Mm-hmm.
this service account, and basically it will
Mm-hmm.
have the same set of permissions, right? And then I would show a couple of other YAMLs
Right.
also very quickly. The namespace.yaml is just to
Mm-hmm.
create the namespace. You can see the kind is namespace. So if you'll see whatever I am deploying, right, my
Okay.
kind is changing everywhere. Like where I'm deploying a cluster role binding, my
Mm-hmm.
kind is cluster role binding. Where I'm deploying the cluster role, it is like kind is cluster role. For the namespace, the kind is namespace. So it is just whatever YAML I'm
Mm-hmm.
deploying, the same I have to mention in the kind, and the name, like whatever name I want to give my
Right.
namespace. And then we have this service and
Right.
the service account. So don't get confused with service and service account. So services are networking part of the
Mm-hmm.
Kubernetes. Like if I want my no container to be accessed outside the cluster or within the cluster, I'll use different types. So the kind would be service, but the
Right.
type would change. Like there are a couple of types like cluster
Mm-hmm.
IP, node port, ingress, load balancer. So load balancer is mostly for the no cloud environments. It won't work in the bare clusters like this. And then we have the cluster IP, where
Mm-hmm.
when we want to have the communication within the cluster itself, like as the name says, cluster IP, right? So it would be allowed, like one
Mm-hmm.
pod would be able to communicate to that specific pod within the cluster. So when we want to expose our applications
Mm-hmm.
and want to be accessed it outside, either we can have a load balancer, but because we are running inside the Docker, we would have this node port. So it is a Docker in Docker, right? So like
Right.
my this application would run on
Mm-hmm.
the top of a Docker, then that Docker was communicating to my host. So directly we won't be able to access via node port, but in real scenarios, we just have to enter this node port and my application would be accessible directly. Here in this scenario, this won't happen because it is
Correct.
the kind
Correct.
cluster. So we would do a small port forwarding
Mm-hmm.
where I would say that whenever the node port is running on 8000, I would say that all the traffic, no, when it is hitting this, like my external IP, that should be redirected to this 8000 port within my no specific Kubernetes node, and inside that this container. So because there are two layers, two
Right.
containers running, so that is why we are just doing the port forwarding. And the last
Okay.
part is the
Makes sense.
service account itself, as we are listening again and again. So service account is just the kind of service account
Mm-hmm.
and the name of the service account and
Mm-hmm.
in which namespace this service account would be there. That is our the service account. So
Right.
these are the only YAMLs which are required when we deploy an application. Like only these things are like you
Mm-hmm.
instead of deployment you can have a replica set or you can have a stateful set. So it will depend, but this is what whenever you want to deploy or whenever I want to create a cluster, right? All these are the only things required. So this is the like minimum
Like these
set
are
of
bare
YAMLs
minimum
what
that
would
you
be.
need.
Correct, 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 correct. So if I have these things,
Okay.
I can deploy the like application wherever I want, or like this is how we can start, right? But if I have idea about all these values and if I'll see something, maybe in our GitHub or in
Mm-hmm.
any host operating system when doing the pen test, we would have idea, right? Like there is a cluster
Mm-hmm.
role, so there should be a service account also, or should be a user also. So it would just give us the idea how the infra has been
Mm-hmm.
created.
Right.
So
Right.
that
Makes sense.
is pretty much it. Let me just close these tabs very quickly. And
Mm-hmm.
so to deploy the application, we don't have to do anything. I'll just go into the folder itself.
Okay.
And because I've already deployed, so I'm not redeploying it, but I'll show you the command. So I just have to go and do
Right.
a
This gives the idea.
kubectl. Correct. So I have kubectl create hyphen f and then name of
Mm-hmm.
the folder itself. Since I'm inside the folder, so I can do a dot itself. So I just
Right.
this kubectl create command will create, and hyphen f is just the set of files or like the folder itself where my all files are. So suppose if I'll go outside this cluster, I
Okay.
have to mention sorry this folder, then I have to mention this full dash rbag, and it will take all the no,
Mm-hmm.
files and it will create everything for me. I can try to create that and I'll show you
Right.
something interesting here. Kubectl
Okay.
create hyphen app and full. So if
Full
I'll do
RBAC.
this,
Yeah.
yes. So you will see it is saying that everything already exists. Like you'll see the role, cluster role is there,
Mm-hmm.
cluster role binding is because I've already created it. So that is why this is showing this error. If if this was not created, then
Correct.
it would create everything for me. Or if I'll make any changes, then it will show
Correct.
configured. So this is our basic
Mm-hmm.
sample application. Now I'll quickly go and just do a code forward so that we can see
Mm-hmm.
what is running on the top. So I think I have missed something. Just let me see what namespace I have given here.
Yeah. I think the namespace. Yeah. 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 Namespace had a different name.
Yes, actually, I was deploying it using a different name, right? So anyway, I'll just copy this namespace and
Okay.
do a port forwarding again.
Mm-hmm.
What is just let me see, right? What has happened?
Sure. Sure. Yeah. I think the service name is also need to
No,
be
actually,
changed.
there are multiple applications running. Like multiple, I have multiple clusters, right? So I think I've deployed
Right.
some
Right.
other
Okay.
cluster. Basically, I'm using a different lab for this, and the cluster is different.
Okay. Okay.
The name which I'm using, that is why it is saying this qctl
Okay.
I've basically copied the wrong command. That is pretty much it. So I'm just seeing what is the name of the
Yeah,
service.
sure.
CTF.
If everything works properly, then it's not a workshop anymore.
So I think you remember right from the day one when we started deployment of the cloud and it's so everything was like not
Hmm.
working in my cluster also. Like something was always down. So just
Yeah. Yeah, I think we just need to change the service name here.
correct. So if you'll see, this actually gives a great way of what we are doing. I'll just explain it. So you can see right now because it was showing a
Hmm.
error that this service is not found and the namespace is not found. So I just use the get svc command in that namespace to see what is the name of my service, and I've
Hmm.
mentioned the name again and the
Hmm.
namespace itself. And now when I'll try, it should work.
Right.
You can see now it has not shown me
Right. Yeah.
any error. So I'll just copy this public IP
Hmm.
and I'll just enter the 8000 here. So,
Hmm.
so this is insecure password manager. So you can see it, the application is working fine, right?
Okay. Thank you, everyone, for joining us in this insightful workshop. This is part one of a multi part series focusing on Kubernetes learning, attack, and defense. We hope you found part one informative and engaging. Stay tuned for part two, where we'll dive deeper into practical strategies of attacking a Kubernetes cluster, which will help in understanding an attacker's mindset and areas that attackers exploit in general. See you soon. Thank you.